Building automation systems, or BAS, a centralized network of software and hardware, which manage various conditions within buildings to enhance occupant comfort and safety while maintaining peak performance. BAS function relies on several key components. Input devices, such as sensors, gather data like temperature and humidity levels. Controllers then process this data and decide actions, such as to increase heating or cooling. Output devices execute these actions to maintain ideal building conditions. Communication protocols, which is a language for the parts to communicate, allow different parts to interact seamlessly. Meanwhile, user interface enable human operators to monitor and control the system. Together, these elements create a comfortable and efficient building environment.
The history of Honeywell can be tracked back to 1886 with Albert Buss, who founded the Buss Thermoelectric Regulator Company. This company was crucial in the early development of automated control systems for heating. Then, in 1906, Mark Honeywell formed the Honeywell Heating Specialty Company, which specialized in improving heating technologies for homes and business. In 1927, these two companies merged, creating the Minneapolis Honeywell Regulator Company, which marked the establishment of Honeywell as we know it today. Since then, Honeywell has developed a wide range of services and products, including aerospace and automotive, control systems, specialty chemicals and plastic, and engineering materials. It is believed that building control began in the 17th century with the invention of the thermostat. Rapid innovation occurred in the 20th century with the introduction of heat regulators and digital controls, leading to the transition to digital building automation. Standards such as BANet emerged, and the global networking began. In the 21st century, building automation started to connect to the cloud and adopt IoT technology, making smart commercial buildings the new standards. It is expected that development will continue in the direction of both green and smart technologies. As mentioned, communication between components of BAS relies on communication protocols. These protocols are sets of messages sent and received between computers and devices, enable control of equipment, data acquisition, and status reporting through a common computer language. This facilitates the operation of devices as an integrated system. Examples include BANet and LOM. For the system we are focusing on today, Honeywell Webs adopted the Niagara framework. This framework uses an open protocol that supports all standard network protocols, including LONWorks, BANets, Modbus, and OBIX. There are numerous benefits to adopting a building automation system. For example, BAS ensure accurate control and identify opportunities for cost-saving improvements. By efficiently managed systems such as HVAC and electrical system, BAS lower energy costs. Additionally, by adjusting parameters such as temperature and lighting, it maintains optimal condition throughout the building. This will not only reduce complaints, but also enhance productivity. Furthermore, by minimizing system breakdown, BAS ensures smooth, uninterrupted operations. This extends the lifespans of equipment and reduces maintenance costs. Integrating a BAS with security system also enhances building safety by allowing real-time monitoring and sends alert about suspicious activities. Additionally, BAS offers the convenience of monitoring and controlling building systems remotely, providing flexibility to respond quickly to any issues. BAS can gather various data through sensors and meters. However, this raw data is not fully useful until it is presented in a format that allows us to make decisions. Dashboards are user interface tools that display critical information from multiple sources in an easily understandable format. They provide relevant and timely information on different aspects involving a building's performance, such as HVAC, electrical, or specialty systems. They can also provide information on energy usage, cost, KPI, trends, and alarm management. The Honeywell Web's dashboard is an online platform equipped with various functions, such as an integrated search tool, customizable charting and visualization options, role-based security settings, real-time issue resolution capabilities, and efficient navigation.
Components of a BAS. Supervisory controllers. The controller is the brain of the automation system. It receives data from the sensors and processes it to determine the appropriate action to maintain the desired environmental conditions within the building. The controller can be dedicated hardware device or software based running on a computer. These supervisory controllers oversee the entire BAS. They collect, store, analyze data from various sensors and devices. The BAS also provides a user-friendly interface for building operators and occupants. This interface may be a graphical dashboard displayed on a computer or mobile device, providing real-time status update alerts and the ability to adjust settings manually if needed. Through this interface, user can adjust control setting, view system status, detect potential issues related to building systems. BAS employs different control modes to manage building system, like DDC, sequential control, BID control, or time-based control. BAS software processes data, executes control strategy, and generate reports. Algorithm optimize energy usage, comfort, and safety. Control systems rely on program algorithms to make decisions based on the input data from sensors. This algorithm can be simple, such as on-off control, or more complex, using PID control or fuzzy logic algorithm to achieve precise and energy-efficient operation. BAS integrates with IT networks for data exchange, cybersecurity, and remote monitoring. Sensors are placed throughout the building to collect on environmental conditions such as temperature, humidity, light levels, occupancy, and air quality. These sensors provide real-time feedback to the control systems. Actuators are devices responsible for executing the commands issued by the controller. For example, HVAC system actuator control valves, dampers, and fans to regulate airflow and temperature. In lighting system, actuator control dimmers or switches to adjust lighting levels. Feedback loop. The control system operates in a feedback loop. It continuously monitors the building condition through sensors, compare them with the desired set points, and adjusts an actuator accordingly. Here is some example of Honeywell control system. Building energy management systems (BEMS) are essential tools for optimizing energy usage and enhance building performance, offer a multitude of advantages for organizations, including energy cost saving. BEMS allows precise monitoring and control of energy usage, resulting in reduced consumption and lower energy costs. Studies indicate that BMS can lead to energy saving of up to 30% in commercial buildings. Improve energy efficiency. By identifying inefficiencies in the building system such as HVAC, lighting, and other equipment, BMS provide insight on optimization. For instance, it can detect underutilization areas and adjust heating and cooling system accordingly, leading to enhanced energy efficiency. The environment benefits. BMS play a crucial role in reducing a building's carbon footprint. This is essential for achieving sustainability goals. By curbing energy consumption and emissions, BMS helps organizations meet regulatory requirements and environmental certification like LEED, BREEAM, BOMER, and Energy Star. For better comfort and productivity, BMS maintains optimal indoor temperature and lighting levels, thereby improving occupant comfort and productivity. A well-regulated environmental, contributes to a better working atmosphere and increased employee satisfaction. Several examples of energy-saving controls that can be utilized. Occupancy sensors. These sensors detect occupancy in rooms or zones and adjust lighting, HVAC, or other systems accordingly. When spaces are occupied, lighting can be dimmed or turned off, and HVAC set points can be adjusted to save energy. Daylight harvesting. Daylight sensors measure natural light level in a space and adjust artificial lighting accordingly. By dimming or turning off lights when sufficient daylight is available, energy consumption can be reduced. Setback and setup scheduling. BMS can schedule HVAC systems to operate at reduced capacity or be turned off during unoccupied periods, such as nights and weekends. By adjusting set points during this time, energy saving can be achieved without compromising comfort. The plug load control. BMS can control power to plug loads such as computers, printers, and other equipment when not in use. By automatically turning off and putting device into low power modes during idle periods, energy saving can be realized. The peak demand management. BMS can manage energy consumption during peak demand periods by shedding non-essential loads or using energy storage systems. By reducing demand changes or avoid peak pricing, significantly cost saving can be achieved. Our Honeywell Webs N4 is a powerful building energy management system (BMS) that enables efficient control and optimization of building operations. Connect an open frame network. Webs N4 builds upon the legacy of Honeywell's Niagara framework. It provides a truly connected and open platform for building management. The intuitive HTML interface ensures fast and easy usability with reduced reliance on browser plugins. The advanced IoT Internet of Things integration. Webs N4 facilitates seamless integration with Internet of Things technology. It allows business to harness IoT data for enhanced visualization, search capability, security, and navigation. The HTML-based user interface simplified and customizations for system integrator, which is a user-friendly interface. Features like built-in search, optimized workflow, and role-based security enhance user interface. The tag-based navigation. Devices, systems, and data point can be tagged, enable efficient station-wide searches. Consistent tagging ensures uniformity in building automation systems. The security and authentication. Web N4 employs a defend in-depth approach, ensure data encryption during transmission and at rest. Role-based access control (RBAC) simplifies user permission and configuration. Development and efficiency. Improved documentation like JavaScript 2.0, semantic data modeling, and public APIs accelerate development. Developer can extend and build on the framework easily. In addition to Web N4, Honeywell's trend branding also offers advanced BMS dashboard that connect people, buildings, and systems through IoT, providing valuable insight for building performance and energy management.
BAS and other systems. BAS can regulate the performance of various facilities within the building. In addition to HVAC systems, it can also control following systems: electrical systems, plumbing systems, lighting systems, security systems, surveillance systems. BAS and lighting systems. BAS can make lighting systems more efficient, save energy, and reduce maintenance costs. Use an occupancy strategy to supply necessary, adequate, and comfortable light utilizing various sensors, and adjust lighting brightness levels according to time of day, weather conditions, and zones of a building. BS can eliminate glare, shine, and other uncomfortable lighting situations. BS and security systems. BS can integrate all parts of a security systems to ensure the security of occupancies and buildings. Manage access to the building by controlling doors and gates. Monitor a building's environment and help to prevent theft, vandalism, and other damages. Monitor and control security systems remotely via computers and smartphones.
For Honeywell Webs, there are three real-life case studies presenting the use of different products in building automation systems. Firstly, we will focus on the Minneapolis-Saint Paul International Airport. The airport is located at Fort Snelling Unorganized Territory, Minnesota. It faces the challenges of integrating different systems into one automated system, including lighting and ventilation control. With more than 90 buildings in the airport, it is a large burden on controlling the systems, optimize the performance, and reduce the energy costs. In this project, Honeywell Niagara Framework and Honeywell Web's Spider Controller are adapted. They provide an open operating system that can connect or control the systems from a web browser. With the assistance of Spider Controller, the airport could also keep the existing sensors, valves, dampers, and wiring. It resulted on reducing more than 25% on construction costs and 50% on maintenance costs. The second case study is the University Health Network of Toronto. It is the largest medical research organization in North America. With different buildings packed together, the outdated HVAC controller system seeks an essential replacement. The goals are to replace the control system to a reliable and efficient one, which can monitor multiple zones at the same time. The comparatively small installation area is also a big challenge in this project. This time, the Honeywell Cypher 50 plant controller, Web 8000 controller, and Web's Niagara Falls systems are adapted to the buildings of University Health Network of Toronto. As this project aims to adapt a modern platform in a small area, Cypher 15 has built-in HOA switches and I/O modules. With a license to scale to 400 points, it provides more economical solution with a greater fun and functionality. It also improved the packed old wiring system, and a panel custom designed by Honeywell fitted to the small installation area, which accommodates all the components of the controllers. The last case study took place in Brighton, Michigan. The Lake Trust Credit Union aimed to adapt well control system, the control iNet, to the new headquarters facility. Goals are to meet workers' needs and not to abandon energy efficiency goal with the standard of LEED certification. In this new headquarters facility, Honeywell Web's Supervisor, Web 700 controller, Spider controller, and TR42 wall modules are used to build the BAS systems. By coordinating all energy-consuming loads in the building, the system helps to save energy and increase the security level to secure the safety of valuable assets, information, and systems. Estimated 11 to 13% of construction costs was saved with a well-designed BAS system, and the facility achieved the goal of LEED certification with outstanding energy efficiency results.
Demand control ventilation. Demand control ventilation is a process in which BAS modifies the ventilation setting point within the building based on the actual occupancy needs. Benefits of demand control ventilation: eliminate excessive ventilation, save energy and money. Eliminate insufficient ventilation, improve comfort and satisfaction of occupancies. Respond timely indoor and outdoor environment changes, utilizing various sensors. Improve indoor air quality by supplying required amounts of fresh air into the building. Technologies of demand control ventilation. Occupancy sensors. Utilize sensors to measure the carbon dioxide level, humidity, and temperature in the area to determine existing occupancy in the zone or area. Carbon dioxide sensors. Install carbon dioxide sensors throughout the building to monitor the occupancy change to adjust ventilating rate accordingly. Occupancy schedules. According to timetables and environment condition changes, to optimize schedules and to modify the rate of ventilation. People counters. Using technologies like takers, security swipers, or camera recognition to count people directly. Conclusion. Demand control ventilation is a control strategy that varies the ventilation rate at which fresh air is delivered to a zone, according to the actual needs in that zone. Their goals are not only to save energy, but also to improve indoor air quality.